So because I'm going to be dealing with different functions today, I'm going to use the notation f of x. If I write something outside of the f of x, you can assume it's like this. After it, if I write it in with the f of x, that you can assume it's inside the function, and I'll show you what that looks like for our three functions today. So you specifically will see that. All right, so let's start with our function f of x. Well, let's start with this. Today, and actually all this week, guys, we're going to go nice and slow. We're going to do all these transformations. And today our transformation is a translation. That is a fancy word for a slide or a shift. So I'm sliding the function left and right, or I'm shifting it. I'm not changing the shape of the graph. I'm not changing how wide it is or anything. Okay? All right, here's our rule for translations or slides. Let's summarize what we just saw. Vertical. What happens when you see a vertical translation or slide is we start with our function f of x. And in our function f of x, we have the ordered pair x, comma, y. Okay, and one of two things happens. Either we have f of x and we add something on the back, so I'll say that plus c. And what happened to the graph? You can just point for me a direction when I added something on the back. This was the first one we did. Which way did it move? Can you just point for me? Okay. This is a shift up C. And so if I wanted to write a new ordered pair, the new ordered pair, the x would stay the same, but the y would be c units taller. Okay, the second thing that could happen, or the second thing that we did, was we did things like this one and that one. So we can either add something on the back or subtract something. So f of x minus c. What way does that move it? Yep, you can just point for me if you want. That shifted things down by c. And so once again, if you were dealing with points, you would not change the x coordinate, but you would move each of the y values down c. So those are our vertical transformations.
Is this the only thing I'm missing?
Yeah, and you haven't missed anything yet. Just this, but you walked in right when we started, right?
Yeah.
Good. And we're recording.
So,
But I won't tell you who it is. For years and years in pre-calculus, I have ones from like 6 years ago that I use over and over again. So really nobody knows anymore anyways. All right, second type. The second type of slide or translation was horizontal or left and right. And when we're dealing with horizontal, I'm going to put a little star here because I said something about x. Okay. Anything that's going to be horizontal with our transformations this week is going to be in this boat. And that is that x is a liar. When I do a translation inside with the x, if it's a plus, it actually moves it to the left. And if it's a minus, it actually moves it to the right. It's a liar. It's opposite of what you would think. So we start with our f of x, just like we did on the last one. And we have our f of x with the ordered pair x, y. And two things could happen. Inside the function now, put it in the parentheses, you could have something subtracted from x. So f of x minus c. And if that happens today, x is a liar, it's in with the x, we are going to move that right by c. And so the ordered pair actually becomes x plus c comma y. So it's the opposite of what you would think. And I wouldn't even look at this part right now because how we're going to see it today is this middle column. That's what you're going to be looking for. All right. In the function, if I have f of x plus something inside the function with it, that's going to move, x is a liar, left, c, so I take the x coordinate and move it left. Okay, so as you're writing that down, our set of three examples, or three sets of examples, we're going to move that onto the next page. So we're going to actually take those down first and just write them down, and then I'll give you some time to glue them in. So I'm going to walk around and give that to you. These are all for you. Okay, example 1. I would have these notes handy so you don't forget. For both of these, I already graphed the absolute value on there for reference. Just something to be aware of. The scale is kind of weird on this. I'm going to put tick marks where there's a 1 because this is a 2. So this is every 2 little grids is a scale of 1. So I'm going to write a couple of those things down. So that's like 3 right there. So I don't forget. This is 1, 2, 3. Let me get it 1. Okay. So, for the very first part of what we do today, can you tell me what the transformation is and sketch a graph? That's it. Looking at our list, let's take a look at g of x first. If f of x was the absolute value of x, how would this graph move? Talk with your partner about that, please. The question is, if this was the original, how would this move according to what we learned today? Okay, Roman Mason, what did you come up with? They said up 3. Thank you. So what I expect for your sketch of your graph today, I don't know why this is a brand new pen. Would you take your graph? Mason, don't put your head on the desk anymore. Take your graph and bump it up 3, so it would be up here, so move your vertex right there. Then what you're going to do to sketch the rest of your graph, remember somebody over here told me earlier, the slopes are 1 and -1. So from that graph, I'm going to go over 1, up 1 to get 2 key points. There's my sketch of G.
Said over 1, up 1.
The slopes of the absolute value things have a slope of 1 and -1, so yes. Once you move your vertex, then you're going to just use a slope of 1 and -1. All right, next, with your partner, would you have a conversation of how h of x moves, and if you feel comfortable, move it? Okay. Riley, what did you guys say? This moves down 2, and so I know this one kind of goes off the paper, but I can still fit it. I move my vertex down to -2. I go over 1, up 1 on either side, and I draw my V. Okay. Do you feel comfortable sketching graphs of that? Let's try translation right and left. Be very, very careful. Would you with your partner, we'll do 2 at once. Would you with your partner tell how g of x moves and how h of x moves? Danny, what did you guys say for g of x?
G of X.
Yep.
We really didn't talk.
Okay. You think it's a shift right
I hope so.
2. You're correct, because x is a liar. Okay, so when that's what it looks like when it's in with x. It's inside the absolute value. Abby, Soraya, what about h? Left 1. So I'm not kind of modeling like what you're going to do on your homework today. You're going to just identify the transformation, then we sketch a graph. So for right 2, I'm literally going to move the vertex. The new vertex would now be at 2, 0. If you want, you could even label it. And I am going to make a line with slope 1, so over 1, up 1, and slope -1. So it would look like this. And there we go for G. Okay, left 1, I move my vertex instead of 0, 0 to -1, 0. And I go over 1, up 1, and over 1, up 1. So slopes of 1 and -1. Okay, so some of the things you're going to graph today are these. By the way, I'm not doing this yet, okay? But I hope you could figure out this one. This moves 2 ways. Can somebody tell me, if I gave you this moves 2 different directions. Somebody give me one of them. Right 2 and up 3. So it would be the same thing. You just move it right 2, up 3. Okay, you could do multiples of that. Okay? All right, good. We'll tape this in a sec. The second kind of graph I want you to look at is this one. And these ones, they're already graphed for you. We're going to just write the equations. All right, hopefully you've seen this graph before. Because I'm a bad paper cutter, some things got cut off probably on yours. Do you see some, like a sentence got cut off?
No.
obtained from the graph of f with the transfer. Okay, here's what you need to know.
Oh, yeah.
The original function on this, we're going to write it down. The original function is x squared. Who remembers studying this in Algebra 1? Okay,
Yeah.
I'm glaring
I
at
really
you.
don't remember it, though.
Okay, x squared, and we graphed things with transformations in Algebra 1. Let me tell you about x squared a little bit. Do you see it's a u, not a v? So be careful when you see x squared graphs today. You're going to still graph your 0, 0. And what point is this? 1, 1. And this is negative 1, 1, right? Aren't those the same points we just did on the other one? Now, you can still graph those three. Just in your head, you're going to know it's a u. Here's why. Let's go out to 2. What's 2 squared? What's 2 squared? 2 squared is 4. So now it starts to curve, okay? Just know today when you're sketching your graphs, make it a parabola. Parabola is the name of it. It has some curvature to it. Okay. So, you tell me this is x squared. Talk with your partner. How does this second graph move from x squared? Aiden, what'd you guys say? It's moving down 3. Okay? So what that looks like is this. You take your x squared, and this is a transformation vertical. Okay? So off the end of it, I literally just subtract 3. So x squared minus 3. That's how it looks in an x squared. There's no bars like in the absolute value. Okay, example 4. Would you talk with your partner how this one moves? Here's x squared. I'll highlight it if in case. This is the x squared. This is the original. Just talk with your partner about how G moved from F, okay? Just tell me what direction and... Ever? Talk with your partner. How does it move? Brian, what did you guys come up with? It moves 3 to the right. If we look at our notes, this is in with the x. Let me show you how you do this in with the x. You actually put a parentheses and you do x. Right 3 is x. X is a liar. Minus 3, and then I put the squared there. So with these graphs, you're going to see a parentheses when it's in with x. If there's no parentheses, that means it's a vertical one. Okay?
Nice.
Last.
You'll never take me. Would you?
Don't test me. This one. Okay, how do I do something like this? I actually physically want you to move the points. That's why I wrote some ordered pairs here, which ones they affect. And honestly, if the graph's right on here, which I made the worksheet so the graphs of these are right on here, you can just take your pen or pencil, and if it's moved to the left, move them over to the left, and so on. Let's just do one of these. This is 2 transformations in one. I'll do this one. Would you guys just circle this one? There's 2 examples here, but I think you're getting this, so. All right. The first thing I want you to do with your partner, there's 2 transformations. I want you to talk. What are the 2 transformations?
Left, number right, and number left. down, right, and up.
Oh, good, Bruce.
X is still a liar, like last year. If it's in like the.
It's just written in function notation, that's the only difference. The thing that's in with X, that's the X. This is the horizontal one. This is the vertical one.
Oh, so.
Okay.
it would've been this.
So,
I'm just more confused on it.
but here's, you're gonna be fine. Here's why.
Understood it until we
You,
got to this
right,
question.
okay, so if I don't have it, any function that I have, if I have it written as function notation, not with square root or squared or absolute value, instead of f of x, it was originally this. Now it's this. The thing that's right here is in with the x. That's your or your horizontal one. The thing on the outside is your one at the end, so that's your vertical one.
What would be plus 3 since X is 1?
So it would be, give me a direction. Right 3, you're right, because x is a liar.
Make sure I know.
Write the transformation, and then
Okay.
up 2. All right. Now, it's not some x squared. Oh, here's all I have. I have these ordered pairs. We're going to just find one of our points, and we're literally going to move it right 3 up 2. You ready? So put your finger on the dot. Some of them might go off the page, and then you just do the ones you can. Take this endpoint. We're going to move it right 3. 1, 2, 3, up 2. Moves up there.
Just connected or no?
Not yet. We're going to graph all of our new points and then connect them at the end. Okay? All right, take this point right here. We're going to move it right 3. 1, 2, 3, up 2. I go in a systematic order, so I'm going from left to right. I'm now going to take the y-intercept, which was right here. I'm going to move it right 3. 1, 2, 3, up 2.
That's too off the board.
The last one will not fit on, right? This bottom one down here, I can do right 3. That's going to be the last one I can do. Up 2. This one I'll just have to do an approximate. All right, now let's connect them from left to right. So we go down, we go up, we go down, we go up. And if you had to, if I gave you the actual ordered pairs, you would just add 3 to the x coordinate and add 2 to the y coordinate. That's all you're doing. Make sense? You guys are rock stars.